All right. Today let's look at a really interesting contact set of contact cards that basically let you do this kind of analysis where we have, if you can imagine that kind of contact that's needed to do this kind of rolling motions, right? It's not exactly frictional, it's not exactly tied. It does some really interesting things. This is the last example I will share, but what we're going to talk about today is let's look at something called like the automatic surface-surface tiebreak contact. This contact option has multiple sort of incarnations, right? You have the single surface tiebreak, you have a general tiebreak, and surface tiebreak. But basically, it gives you the option to do a few things that you wouldn't expect to be able to do in other type of contact, and that's what I'm going to review today. I'm going to review four different possibilities within this slide deck. No, there's no demo this week, not much to it, but it's really interesting to know what's possible because you can use this contact card to do a lot of interesting simulations. Because that's how you're going to represent the physics. Okay, so we'll have four different options we can look at. We can look at option one, which means it's a contact that starts as a frictional contact but ends as a tied contact. Option two, we're gonna start as a frictional contact but ends tied, and the tie can break if the tie break condition is satisfied. Option four is very much like a no separation contact from Ansys Mechanical. Basically, it's a sort of a linear contact that can slide but not separate. So this is something that's very default, very usually used inside Ansys Mechanical. In Dyna, this is how you do it, is with an option four of the automatic surface-to-surface tie break contact. You can also do a single surface contact, which means you have a piece of material that sort of tied to itself as it goes around a circle, for example, which is sort of like what I have right here, if you can think about that. And there are other options that allow you to define damage behavior, bonding behavior, which is the more advanced version of this contact pair. That's something that I don't have a lot of material data for, so I won't try to demo it. But if you look at the documentation for this contact pair, you'll be able to find some really interesting stuff. Okay, so that's the deal. Okay, just a slide deck, right? Option one, start automatic, start frictional, ends tied. So this is the basic format in the option. Key parameter, you set it to one. You don't really need to set any and FLS and SFLS as the normal and shear tiebreak criteria. You don't have to set it in this case. And once you do so to a contact like this, right, what you have is like gonna start frictional and then ends tied. So this is very useful for a situation that look like this. If you can imagine this pin, right? This pin start by coming down to pick up this paper. So you're gonna start with a gap, and it's gonna hit the paper. Once it hits the quote unquote paper, it's going to pick it up, and you can sort of see this is the kind of contact you can do with this option one of the automatic tiebreak contact, right? So you can sort of see this basically starts as a gap, close the gap, and then you can pull it up, and this automatic contact becomes a tied contact, and that's what allows you to have this kind of motions. Okay. All right. Option two, if we start tied but it allows a tangential motion after meeting the criteria, right? So what is an example of this? This is very much like a tie-break contact in general, right? But it allows you to have some type of tangential effect, but not a normal effect. So let's take a look at what this does. All right, so same thing, right? Tie-break is active initially, but until further tangential motion is inhibited. You cannot have tangential motions, but you can have normal motions in a sense. So let's look at how this is used, right? So for example, this is the stress. So for example, so in this case, what happens is I'm trying to move this post to the left or to the right, but it's not letting me do that until it reaches that threshold for the contact pressure, right? And then over here, you have the interface force, which means that you start with some interface force until it reaches around the threshold, then it's able to slide. So this is basically like a tie break contact, is what this option essentially does. Now, if we look at option four, which is very much like the no separation contact inside Ansys Mechanical, right? So in this case, you set option to four, still no criteria, right? So what this does is that if you look at an example model like this, you can basically slide across the face, right? In this tight kind of contact, there's no resistance, but as long as you apply a normal force to it, it allow you to pick up that piece of paper, quote unquote, right? So what this allow you to do basically, right, is very much like a no separation contact in Ansys mechanical, right? There is the contact cannot separate, but you can slide, which obviously comes in handy in a lot of situations in which you want to you want the contact to follow each other along that path. Okay, and that's something that's actually missing in the default contact cards inside LS-Dyna. I know many years ago I've asked the question how to do that. People couldn't answer, but now I have a solution, and we have a solution that we can look at. Very, very useful. Okay. Now, if we look at a single surface type of single surface contact, a single surface contact basically allow you to sort of define a single body of 999 of this little sheet of paper right here. And if you were to do that, it allows you to basically create a option based on that single surface contact. In this case, if I were to just roll this, you can sort of see I can have the sort of this piece of material. It's going to be rolled around the roller and onto itself, right? So that's a pretty convenient thing to do if you think about it. Like what kind of contact can do this kind of behaviors, right? It's not a tie contact. It's also not a frictional contact, right? It starts frictional and then it goes into tie is the key idea here. You can see that's a pretty clean way to do that, right? I didn't show any of the example model because it's not really as necessary. Like the roller one, slightly interesting. So in the roller one, I guess I can just quickly demonstrate it, right? So I have some amount of displacement control around the two edges of the plate, so it cannot move side to side or up and down. It just becomes stationary there. It just becomes stationary in the y directions, and then I have a displacement control on the other side as well. And then on the remote displacement control here, this thing is rolling right in this direction, essentially 10 rotations across the board. This thing is also going to translate 200 millimeter to the z-axis. At the same time, it doesn't have any sort of like linear kind of x-axis motion. And what I do is I put some pressure on it. This pressure allows you to put some compression on the sheet, which allows you to grab it. That's where the tie contact becomes an automatic kind of becomes a tie contact because initially I actually have a gap. You can see that, right? This gap is going to be closed by this pressure force. Alternatively, what I can also do is to apply a displacement control. A displacement control, which is very much like what I have here, right? This displacement control also allow you to just add a little bit of displacement initially until you hit that sheet of paper, and then it's gonna wrap it around. And as it wrap it, this roller is slightly raised to allow the space, because if you don't raise it up, there's no space for the material to wrap around it, and that becomes a problem. And that's in essence what this contact card is. And I have a single surface contact down here that's going to be using the single surface contact that you see right here to basically handle it. All right, that's the review for the automatic surface tiebreak options. This is an extremely useful contact card in Dyna. Very unique in my opinion, and it has even more functionality that I have not shared because it involves damage laws and such that I don't have data for. So it doesn't make a lot of sense for me to present it. But take a look at the documentation. It's going to be a very useful contact card for a lot of physics that we're trying to model. All right, thank you very much.